Okay, going on to topic 5 now of module 4. There are only 6 examples, so we'll do each one item by item. So let's write this out here. Square root of x minus 4 equals 5. Well, the key to solving equations with radicals in it is to isolate the radical. So we're going to transpose this. This becomes a 9, and we have the square root of x. Now the key to solving this is to get rid of the radical sign. Well, how do we get rid of the radical sign? Well, we do so by squaring both sides. Now notice that this index number is 2 here, and outside is 2. So if we take away the radical sign and put the 2 under there, this is a 1. So it just becomes the x. So once again, the shortcut is whatever this index number is here, if you put it there, it just becomes the radicand. And this is 81. And that's the answer. All right, let's go on to example 2. So we have the square root of x. Now what I'm going to do is take this positive 10, bring it to this side, and I get a negative 2 there. So I'm just transposing the positive 10 to the other side, making it a negative 10. I get a negative 2. Now notice what you see here. You're saying the square root of x is a negative 2. Is that going to be a real number? Can the square root of something be a negative? And the answer is no. So for this, there is no solution. All right, going on to number 3, or letter C, I should say. We have x equals the square root of x plus 8 minus 2. So once again, the rule is to isolate the radical. So we're going to transpose this 2 to the other side. So we get x plus 2 equals the square root of x plus 8. Now the rule here is the same. To get rid of the radical sign, we want to raise it to the power of the index number. But if we do it to one side, we must do it to the other. So this then is going to be squaring a binomial, which we've had a number of times. Square this term, multiply this, double it, and square this term. And now this just becomes the radicand. We then integrate this into the other side, so we get x squared. This becomes a negative 3x, and this becomes a, on this side, a negative 4. Be careful of your signs. Now we factor that. And this needs to be a positive, and this is a negative. So in a sense, we're finding the zeros. So this will be its opposite sign, and this will be its opposite sign. Now, when we square things, from time to time we introduce erroneous roots, that is, solutions that don't work. And let's just check this one out here. This one works. So let's just do it here. This is a 1. And this will be 1 plus 8 is 9. Square root of 9 is 3. So 3 minus 2, that is a solution. So this one works. Now a negative 4, this will be a negative 4. This will be a negative 4. This becomes a 4. Square root of 4 is 4. Well, 4. Square root of 4 is 2. 2 minus 2 is 0. This one does not check. So this is an erroneous answer. Again, if you did all this and you have that, I will give partial credit on a test, but to get full credit, this is the answer. So you need to be careful of that and, in a sense, check your work. All right, let's go on to letter D, which is 3x plus 2 raised to the 1/3 power plus 4 equals 0. Now another way to look at that, you could do it this way too, but another way to look at that, this is the 3rd root of 3x plus 2. I'm going to transpose that. It becomes a negative 4 on that side. So here we're just going to raise this to the 3rd power. Index number there, raised to that power to both sides. And another way of doing that would have been putting a bracket up here and raising this to the 3rd power here. These would just cancel out and you'd end up with this. So this is the same. We just end up with the radicand. And we're cubing this, negative 64. Now we're bringing this over as a negative 66. Going to divide by 3. X equals a negative 22. And if you put a negative 22 in there, you get a negative 66. Plus 2 is a negative 64. The cube root of a negative 64 is a negative 4. Negative 4 plus 4 equals 0. Or negative 4 equals negative 4. So this one checks and it's a good solution. Let's go on. We now have the square root of 4x plus 1 equals the square root of 3x minus 5 plus 2. Now what we need to do here, again, we have a radical on this side and a radical on this side. So we can't isolate it any more than that. We've isolated one, which is the way the problem is set up. So we're going to square this side and we're going to square this side. Now again, the nice thing, when this is 2, index number is 2 and you're raising it to the 2nd power, it just becomes the radicand. Now here we're in a sense squaring a binomial. So we're squaring this first term, which just becomes the radicand. We're now going to multiply these together and then double it. So this is 2 times this, so it becomes 4 times that. And we square this term. That was from that old a plus b, the quantity squared. You square the first term, multiply these two together and double it, and square the last term. So using that technique, that's what we're doing here. We're squaring that first term, which just gives us the radicand, and then we're multiplying these together and doubling it, so this 2 becomes a 4, and then we have the last term that we squared. Now we're going to collect like terms and isolate the radical. So let's see what we have here. We have 4x plus 1 equals, nothing to combine there. Now we have a negative 5 and a positive 4. That will give us a negative 1 plus 4, the square root of 3x minus 5. Okay, now we want to get these terms to the other side. So we're going to subtract 3x here. From there we get x. We're going to add 1, we get this. So lots of stuff going on. But we've isolated the radical. So now we're going to square both sides. Here we're just squaring this binomial again. It becomes x squared plus, multiply this together, double it, square this term. Now when we square the 4 here, that gives us a 16. And then when we square this, that becomes its radicand. So again, we clear parentheses. X squared plus 4x plus 4 equals 48. And then this is a negative 5 times 16 will be a negative 80. Now we integrate to the other side by transposition. This gives us x squared. Now on this side, this becomes a negative 44x. This is going to become a positive 84 equals 0. Now we factor that, and we get an x and an x. And I don't know if you can see it. If you go divide this by 2, this gives you a 42 and a 2. Multiplying these together, you get that, and they both have to be negative. So for a solution, we get x equals 2, equaling this to 0 here, or x equals 42. And actually both of these check. Okay. Wow. Lots of stuff going on. All right, let's go on to our next one. It's a little more complicated, but not too bad. So we have the square root of x plus 10 minus the square root of x minus 7 equals, so this is part of it, and then it equals 1. Now when we have two radicals like this, again, we want to isolate one of them. So I'm going to move this one to the other side. So we get x, the square root of x plus 10 equals 1 plus the square root of x minus 7. All I'm doing is taking this radical with a negative, transposing it. Now what we're going to do is square both sides. And this technique of squaring a binomial is very useful. Here it just becomes the radicand. Note if the index number is 2, which it is, and we raise it to the second power, it just becomes the radicand. Now we're going to square 1 and get 1. Multiply these two together and double it. That'll give us 2, the square root of x minus 7. And now we're going to square this, and it just becomes the radicand. So index number, squaring it, just the radicand. Now we're going to organize our terms here. Now here I have a 1. Here I have a negative 7. And I also have an x. So I could put that x right there. And this is going to become a negative 6 plus 2, the square root of x minus 7. So I have a 1 and a negative 7. That gives me the negative 6. I'm just putting this x right here. Because what happens now? Well, I subtract x from both sides, and to save room, I'm just going to erase it, because those cancel out. And now I'm going to transpose this negative 6 to this side. So add 6, add 6. This is going to become a 16. And then this is gone now. Just saving a little room. So this is what I have. Now notice I have a factor of 2 here and a factor or 16. I could divide both sides by a 2. So this then becomes 8 equals the square root of x minus 7. So a lot simpler than what we had up here. So again, we're going to square both sides. Raising this radical to its index number just gives me the radicand. Now I'm going to take this negative 7. To get rid of it, I have to add 7 or just transpose it. This gives me a 71 equals x, and that checks. So not too bad. Lots of stuff going on, lots of algebra that we've learned, and hopefully you can do well on the examples you get on your practice and quiz me.